Welcome back. Last lesson, we looked at how to scope your personal Solana resource needs. Today, we are shifting gears for a lesson brought to you by Forge College. We have arrived at the capstone of our Introduction to Ethereum Architecture course. This is the moment where we pull everything from the Ethereum fundamentals track together. Blockchains present a unique challenge. They are essentially invisible code floating across a network. How do we accurately draw the difference between Bitcoin and Ethereum without just scaring at thousands of lines of data? The secret is simple. We don't need more technical jargon. We just need the right visual metaphors to translate the abstract into familiar shapes. For our drafting session, we'll use a strict engineering style, just orange and dark green ink on beige paper. This minimalist approach helps us map out these massive networks without getting lost in the weeds. A good metaphor does the heavy lifting for us. It turns a confusing, cryptographic mystery into a map that your brain can intuitively navigate. Our first major contrast is state representation, which is really just a fancy way of saying how the network remembers who owns what. Bitcoin uses a system called UTXO. Think of this like the physical bills in your wallet. You don't have a balance at the store. You have a collection of specific, unspent pieces of paper that you haven't used yet. It's like a massive library card catalog filled with dated receipts. To buy something, you hand over an old receipt and the system gives you a brand new one back as your change. Ethereum handles this using a structure called a state tree. Think of a tree as a branching directory, a tree where the path you take determines exactly which piece of information you find at the end. Imagine a city map where neighborhoods and addresses are the keys to finding someone. Each account is a house, and your balance is simply written on the front door. To change that balance, a worker has to walk down those specific streets to reach the house and update it. This creates a major distinction. Bitcoin is a library of discrete, separate receipts, while Ethereum is a hierarchical map where everything is connected by specific paths. Because updating a house on the city map requires a worker to physically navigate the streets and perform maintenance, it costs energy and time, meaning every change has a price and must happen in a specific order to keep the map accurate. Now let's look at block and header anatomy, the way these networks bundle their data for delivery. A Bitcoin block is a static snapshot. It's like taking a single photograph of that pile of library receipts to prove they existed at a certain time. In this drawing, the Bitcoin block is a sealed envelope. It only needs one Merkle root, a single digital fingerprint that acts as a seal summary. If even one receipt inside the envelope is changed, that seal breaks instantly. Ethereum's block header is much busier. It isn't just a static photo of the past. It's an active blueprint for a shared global computer. See how the envelope opens into a file folder with labeled tabs. These are the header fields. We have a tab for transactions, one for the state root, and one for the receipts root, which tracks the outcome of all that work. That state root tab is the most important part. It is a direct pointer back to our city map, ensuring the block is linked to the most up-to-date version of who owns what across the whole network. While Bitcoin blocks focus on agreeing that a list of events happened, Ethereum blocks focus on agreeing on the exact state of the world after those events are finished. Finally, we need to add the people doing the actual labor, the operational roles. This is a full node. Think of it as a heavy-duty workbench. The solid cylinders represent the storage where the entire city map is tapped, and the bench itself is where the computational work happens. A light client is different. It's an inspector with a magnifying glass. They don't have the space for a full workbench or the whole map. They only look at the folder tabs to make sure the workbenches aren't lying to them. When you put the city map, the open folder, and the workbench together, you get a complete architectural map of how Ethereum functions. This explains why we pay gas fees. You're paying the workbench operators for the maintenance required to update the city map. And because the map must remain consistent, your transactions have to be processed in a very specific order. These visual models give you a structural lens to navigate and build within the Ethereum ecosystem. You can see the logic behind the code. This concludes our illustrated comparison of Ethereum and Bitcoin. This video was created by Forge College. To learn more about these architectures and explore other Web3 topics, visit forge.college. We'll see you in the next lesson.